Welcome to Singularity Vault. Our channel is your one-stop destination for all things science and technology. Make sure to subscribe and hit the bell for regular updates. Why aren't we zipping up and down space elevators or charging our phones with revolutionary graphene batteries yet? That's the question of the hour, isn't it? Just over a decade ago, graphene burst onto the scene with all the fanfare of a Hollywood blockbuster. Scientists and engineers were head over heels for this one-atom-thick layer of carbon atoms. Its properties read like a laundry list from a superhero's resume. Stronger than steel, yet incredibly light. A better conductor of electricity than copper. Transparent, flexible, and even impermeable to gases. It was hailed as the wonder material that would revolutionize everything from electronics to energy to aerospace. Yet here we are, still waiting for our space elevators and graphene-powered batteries. We were promised a future where skyscrapers would be held together by graphene-reinforced concrete, and our devices would be powered by super-fast, super-efficient graphene circuits. A future where we could zip up to a space station as easily as catching an elevator to the top floor of a high-rise building. But if you look around, you'll notice that our world is conspicuously short on graphene wonders. Instead of charging our phones in a blink, we're still tethered to our old lithium-ion batteries. Instead of whizzing up and down space elevators, we're still relying on good old-fashioned rockets. So what happened? Where's the gap between these grand promises and our current reality? Did we fall victim to over-optimism, or are there genuine challenges holding us back? Well, as it turns out, there's a bit more to the story than just the grand promises. Translating the extraordinary properties of graphene from the lab to real-world applications is a bit like trying to herd cats. It's not impossible, but it does require a certain finesse. It's a tale of engineering quirks, practical challenges, and the occasional stroke of genius. A tale that's as fascinating as it is frustrating. But don't lose hope just yet. Because while graphene's grand promises might be taking a bit longer to materialize, the journey is far from over. Turns out there's a bit more to the story than just the grand promises. Why is graphene, the wonder material, so hard to tame? You might have heard of graphene as the material that will revolutionize everything from electronics to medicine to space travel. It's been called the material of the future, with scientists raving about its incredible strength, flexibility, and conductivity. But if graphene is so fantastic, why isn't it everywhere? Why aren't we charging our phones in seconds or riding space elevators? Well, the answer lies in the quirky world of graphene engineering. Simply put, graphene is a moody superstar. It's got all the talent, but it's incredibly hard to manage. Firstly, making graphene is not a piece of cake. In the lab, scientists can create tiny flakes of graphene using sticky tape and graphite. Yes, the stuff in your pencil. It's like peeling an onion, layer by layer, until you're left with a single atom-thick sheet of carbon atoms arranged in a honeycomb lattice. But try doing that on a large scale, and you'll quickly realize it's about as practical as knitting a sweater with spaghetti. Then, there's the problem of quality. Not all graphene is created equal. The slightest imperfection can severely affect its properties. It's like baking a souffle. The smallest mistake can make it collapse. And when you're dealing with atoms, avoiding mistakes is a Herculean task. Even when we do manage to produce high-quality graphene, incorporating it into existing technologies is another hurdle. It's like trying to teach an old dog new tricks. Many of our current manufacturing processes and devices aren't designed to work with a material that's only one atom thick. And if that wasn't enough, there's a whole other side to the story. Graphene might be a superstar in the lab, but when it comes to real-world applications, it's a bit of a diva. It doesn't always play nice with other materials, and it can be incredibly sensitive to its environment. For example, it loses its superconductivity when exposed to air. It's like a prima donna refusing to perform because the lighting isn't just right. So, while scientists have made impressive strides in understanding graphene's potential, translating those laboratory successes into practical applications is a complex and often frustrating process. It's like trying to herd cats. No matter how much you want them to go in one direction, they seem determined to do their own thing. But don't lose hope just yet. Scientists and engineers are hard at work taming this unruly material. They're finding new ways to produce, manipulate, and incorporate graphene, And who knows, maybe in a few years, we'll be charging our phones in seconds or even riding space elevators. Graphene might be a wonder material, but it's proving to be a bit of a diva in the engineering world. Despite all the hurdles, graphene has had its share of eureka moments. Now let's dive into some of these exciting breakthroughs. In a groundbreaking moment in January of 2024, Dahir and his team from Georgia Tech achieved a major milestone by unlocking the secrets of growing graphene on silicon carbide wafers, employing specialized furnaces in their process. This innovative technique yielded epitaxial graphene, a single-layer wonder that emerges on a crystal face of the silicon carbide. Extensive measurements conducted by the team revealed a remarkable finding. Their graphene semiconductor boasts 10 times greater mobility than traditional silicon. To put it simply, electrons navigate with minimal resistance, paving the way for accelerated computing in the realm of electronics. At present, their creation stands as the sole two-dimensional semiconductor, possessing all the essential attributes for integration into the realm of nanoelectronics. What about the world of communication? Well, graphene might just have an answer for that too. Researchers are exploring graphene antennas, which could potentially provide ultra-fast wireless communication in the terahertz range, making it more efficient than any traditional antenna designs. Now that's something to get excited about. All these advancements, these eureka moments, are signs of progress. They're stepping stones towards the grand promises that graphene holds. Yes, we've had our share of hurdles, and yes, we've had our share of disappointments. But every breakthrough, every eureka moment, brings us closer to realizing the potential of this wonder material. And remember, the journey of 1,000 miles begins with a single step. With graphene, we've taken more than just a few steps. We're well on our way, navigating the winding path of innovation and discovery. With every eureka moment, we inch closer to the grand promises of graphene. And who knows, maybe the next eureka is just around the corner. So when can we expect to witness the full potential of graphene? Now that's a question we all have been flirting with for quite some time. In the last 15 years, we've seen some significant strides in graphene research. We've been able to synthesize it, manipulate it, and even understand its properties a bit better. Let's delve deeper into the details. The production challenges. Creating, manipulating graphene that is strong and durable enough for practical applications is no small feat. It needs to be synthesized with precision and expertise, and withstand all sorts of threats, from high temperatures to chemical reactions. But don't let these challenges dampen your spirits. While we might not be able to harness the full potential of graphene tomorrow, there's a lot of progress being made. Scientists around the world are working tirelessly to overcome these obstacles. We're seeing exciting developments in the fields of materials, science, engineering, and nanotechnology that could one day make our graphene-dominated future a reality. And it's not just confined to theoretical applications. Practical uses of graphene, like revolutionary batteries, are also on the horizon. Imagine a world where your phone battery lasts for weeks, not hours, or where electric cars can be charged in the time it takes to grab a cup of coffee. These are the kinds of breakthroughs that graphene promises, and they're closer than you might think. So, when will we witness the full potential of graphene? Well, it's hard to say. These things take time, and there are still many challenges to overcome. But with the pace of scientific discovery accelerating, who knows? We might just see these wonders in our lifetimes. While we can't mark the date on our calendars yet, the future of graphene looks promising. From grand promises to engineering quirks, graphene's journey has been quite the rollercoaster ride. We've navigated through the landscape of graphene's great promises, from space elevators to revolutionary batteries, and faced the stark reality check of why they're not part of our everyday lives yet. We've chuckled over the challenges of mass production and integrating graphene into existing technologies, proving that even the most promising materials have their own set of peculiarities. But then, we've also celebrated the recent eureka moments in graphene research. The groundbreaking work at Georgia Tech, for instance, is a testament to the fact that with every hurdle, there's a new discovery waiting just around the corner. So, while we may not be riding our space elevators just yet, the journey towards that future continues, and you're all part of it. So, share your thoughts, Your dreams about graphene's possibilities. Until we ride our space elevators, let's keep dreaming big and pushing the boundaries of what's possible with graphene.